Hey everyone, I'm Burhan with another tutorial on PCB designing using KiCad. In the previous tutorial, we designed this average looking schematic. Although this schematic is good for personal reference and we can design PCBs from it, but we can't share it with anyone as it has so many wires crossing each other, which makes it a bit hectic to understand which wire is coming from which component and going to which component. So in this tutorial, we will use some interesting tools and features of KiCad to prettify our schematic. But before going to the schematic, let's have a look at the bottom right corner of our document sheet. This is the title box. And let's first see how we can customize our title box. You can either click on the page settings icon here, or you can go to the file and click on page settings. Here you can add the information that's required on the document. First, we will start by inserting the current date. If you wish to enter any other date, you can also do that, but let's insert the current date. Then there is this revision section. Revision is associated with what we call as hierarchy, and since we have not discussed that yet, so for now we just remember we are on version 1 of our project. Then we have the title, and I'll enter transformerless power supply. In company section, we have possible code. You can add additional information about a project in these comment sections. Now let me click OK, and you can see the information is added here. Now, just like the components, each connection has its own name. For example, if I click on this connection, its name gets reflected at the bottom. Similarly, every connection has its own name. This is a very powerful feature of KiCad because even if the pins are not physically connected, still the pins with same net name are connected in the backend by KiCad. Using this feature allows us to avoid unnecessary overlapping of wires. So the name ground is because of the power symbol which I have used here. Similarly, if I use any other power symbol, say 5 volt, at this point, you can see the net name of this connection gets updated to 5 volt. But since I have used only one power symbol that's ground in the whole project, the rest of the components, rest of the connections don't carry any net name. For example, if I click on this connection, it doesn't have a net name. For all such connections, we can create custom net names. And in order to do so, just click on this add a net label. Let me name it output and add it here. Okay, output is added here. Now, if I click on this connection here, you can see its name has got updated to output. Let me duplicate this power symbol from here and add it here. The net name of this connection will also become out. Let me delete these wires first. Okay, so even if the pins are not physically connected, still these three pins, pin 2 and one pin of this resistor and pin 1 of the secure terminal, these are connected in the backend by KiCad because they have the same net name. Let me quickly do it for all the pins. Okay, so net name assignment is done. Now we can make different sections of our circuit, which makes it easy to understand. Uh, First, we will use this add text tool to name different sections of my circuit. So let me name it. Now, in order to separate these sections into individual units, I'll make use of these tools. For now, I'll use this rectangle tool. Okay, it's looking nice. Let me do it quickly for all the sections. Now, if you compare this schematic with the previous one, you will realize how understandable it is. Now, in order to make it much better, you can also add logos. In order to add logos, click on Place, Add Image, and I'll choose the logo of our channel. Moreover, if you wish to open source your project and want to add the link to your website, GitHub, or LinkedIn profile, you can also do that. Just click on Add Text Box, add your text box here, and enter the link. I'll enter the link of our website. Okay, so our website is added here. With this, our schematic is complete. But before going ahead, we need to run an ERC or electrical rules check to see if our schematic is in accordance with electrical rules. To see these rules, just go to schematic setup and under this click on electrical rules. This is the list of electrical rules which KiCad has set up for us. For example, pin not connected, input pin not driven by the output pin, etc. So let's run an ERC for our circuit. For that, click on perform electrical rules check from here, or you can go to inspect and electrical rules checker, run ERC. Okay, so we have zero warnings and three errors. Let's check them one by one. First error is input power pin not driven by any output power pin. Second one is pin not connected, and third one is out input power pin not driven by any output power pin. Okay, so let's try to resolve these issues. First, we'll okay. So here we have an unconnected pin. Let's use a no connection flag here. Run ARC again. So now we have only two errors. And these both errors are same, that is input power pin not driven by any output power pin. And these errors usually arise because KiCad doesn't know from where the power is coming to our pins. So let's try to resolve it by using a power flag. Okay, so run ERC again. We have zero errors. While performing ERC, you can face a lot of errors, and discussing all of them is not possible. However, most of the errors are self-explanatory and you can resolve them by yourself. Still, if you need any help, you can connect us on our website. With this, our schematic is complete. However, the components which we have used in our schematic are generic. That is, we have not specified whether our components are SMD or THT, what their size is, and these specifications need to be taken care of while designing a PCB. So, in order to provide the information about the actual physical components which we'll be using on our PCB after its fabrication, we need to assign footprints. Now, in order to assign footprints, click on Tools and then click on Assign Footprints. Here is a list of all components which you have used in our schematic. Here at the top, you have some footprint filters which will reduce your footprint hunting time. For example, if I choose this capacitor, choose capacitor from this side, and apply the first filter which filters out the footprints based on the symbol, then this filter will show me only capacitors, be it SMD or be it THT. And the available options which I have are 312. Similarly, if I apply second filter, which filters out the footprints based on pin count, it will show me those footprints which have two pins, be it battery holder, be it a capacitor, be it a button, buzzer, button, resistor, diode. It will show me all those components, all those footprints which have two pins. Similar, and the option here is number of options available for me is uh, 2416. Similarly, if I apply the third filter, which filters out the footprints based on the library, then it will show me only capacitor THT, not SMD. So it's better to apply all these filters at the same time. And available option for me is now 262. I will have to choose among these 262 options. If you wish to view any footprint, just hover your cursor over it, right click on it, view selected footprint, and here is your footprint. If you wish to view its 3D version, click Alt 3 on your keyboard, and here is the 3D version. Also, you can view its 3D version by clicking on this capacitor-like icon. And if I have to assign any footprint, I'll have to double click on it. It's assigned here. So let me quickly assign footprints for rest of the components. Okay, so I have assigned footprints for all components except this variable voltage regulator IC. Although KiCad has option for it, but I will not use that. If you remember from the previous tutorial, along with the symbol of LM317, I also downloaded the footprint. So I will use that footprint to show you how you can import the footprint. In the previous tutorial, I showed you how you can import the symbol. So you can import the footprint by clicking on this edit the global and project footprint library lists, or we can add it in the schematic editor. Click on create, delete, and edit footprints. Then click on File, create a new library. I'll create it as project. It's created here. Right click on it, import footprint, and it's here. Okay, so let's save it first. Let me go back to the footprint assignment window. Let's search for demo. It's created here, and you can see our footprint is here. This is our footprint. Okay, now click on apply, save schematic, and continue, and click OK. This is all about this tutorial. In the next tutorial, we will start creating the actual PCB with actual dimensions and actual routing. At last, if you like this kind of content, then you should think about becoming a channel subscriber. Thank you so much.